Welcome, everyone. My name is Ricardo Camacho, and I'm the Director of Regulatory Safety and Security Compliance at Parasoft. Today, I'm here with Miroslav Zielinski, Director of Product Management, and we both thank you for joining us today for this webinar to demonstrate not just the integration, but how to deploy a CI/CD static analysis workflow with Parasoft CC++ Test and GitHub. Mirek is also presenting to us from way out in Europe. Why don't you give us a hi, Mirek?
Hello, everybody.
Thank you. Now let's start by taking a look at the agenda. I'd like to start by giving you a quick glimpse overview of CC++ test, just some of the highlights because it's been evolving so quickly that I want to make sure that you are up to date with all the wonderful capabilities. I'm going to then pass it off to Mirek. He will be giving us a live demo of employing a modern development agile workflow, and I would say something that Parasoft is exceptional at. Anyways, Mirek will take us through a full workflow and demo of CC++ test with the GitHub integration. And I'd like to add that I really like this development ecosystem that Mirek's going to demonstrate. It makes for a very attractive CI/CD development workflow. Okay, I will then at the end open it up for live Q&A. So let's get started. Demands and requirements in software safety and security keep increasing. Testing using various complementing testing methods like static analysis, unit testing, code coverage, and others help ensure delivery of safe and secure, reliable code. But not all testing solutions out there have a comprehensive offering. However, Parasoft offers CC++ Test, a unified, fully integrated testing solution for C and C++ software development. Within CC++ Test, users can perform static analysis, unit testing, integration testing, system testing, and structural code coverage. We also offer a collection of other testing tools that perform API testing, UI testing, service virtualization, and more. But that's for another webinar. Anyway, with CC++ Test, users can also test on target hardware and generate reports needed to show evidence of compliance to functional safety and security standards. Now, speaking of standards, Parasoft helps satisfy many functional safety and security standards as it relates to software verification and validation. We provide the testing methods recommended or mandated by these standards. And we also help satisfy the verification needs and requirements through linking requirements to test cases and fulfilling the traceability matrix required by these process standards. We integrate with various ALM tools or requirements management tools like JAMA, as you see here. Anyway, this traceability matrix shows on the far right the test cases that verify and validate particular requirements. The red box highlights gaps in requirement decomposition and missing tests. The traceability matrix makes it very visual and is required by functional safety standards like ISO 262 in automotive, DO 178C in Mil-Aero, IEC 62304 in medical, and others as you see here. Also, be aware that this also applies to security process standards like ISO 21434 in automotive, DO 326A in Mil-Aero, and the up-and-coming IEC 81001 Part 5 for the medical industry. That medical cybersecurity standard is anticipated to be published in May of 2024, so I'm sure I'll be delivering a webinar on this topic. Moving forward, I wanted to give you a little bit more on requirements. This slide provides additional visuals of our requirement solution. The Parasoft dashboard on the right, the Parasoft traceability matrix on the bottom left. We also provide bidirectional traceability between requirements and the test cases, so you can easily navigate between tools. The integration also allows users to link down to the code if desired. Also, the test results can be exported into the ALM tool. The ALM requirements traceability matrix can then be completed and fulfilled as required by the standards. Continuing with other types of standards, Parasoft leads the industry with our 100% complete support for the latest MISRA C 2023 coding standard. As members of the MISRA C and C++ working groups actively developing MISRA, Parasoft is committed to immediately incorporating the latest coding standards into our testing solutions. This helps organizations deliver the safest, the most secure, and the most reliable applications. But this is not just for MISRA. The case is the same for other coding standards that we also provide, like AutoSAR, C++14, CERT, CWE, OWASP, and many others on our list. We also provide the ability for users to customize these coding configurations. Users can enable or disable rules, they can define their own configurations, and even create their own rules if they desire. Also, we generate all the required reports needed to demonstrate compliance as defined by the coding standards. This is accomplished by way of our DTP dashboard, reporting and analytics solution. So you're seeing a screenshot of that. The dashboard also shows how your team is progressing towards compliance and actually quite a lot more information. A key point that I want to bring to you is that Parasoft has a complete and solid static analysis solution. Verification of the software on the target hardware may also be a compliance requirement for you. For many safety critical embedded applications, target based testing is essential in order to validate for correct functionality, security, and performance. I highly recommend that you do start by testing on the host or virtual environment, which is exceptionally easy with C++ test. This initial testing has many benefits, such as testing early in the software development lifecycle and fixing those bugs early, because it gets more expensive to fix the bugs later down the software development lifecycle. It cuts cost and labor, improves code quality, and shortens time to market. However, if testing or when testing on the target is required, C++ Test supports many target environments, compilers, IDEs, and debuggers. You can build and deploy your applications directly onto the target hardware and connect to the target through various ports such as serial, Ethernet, JTAG, and other methods. You can run your test and collect test results from unit testing and code coverage of statement, branch, and MCDC if you need. Now, part of the testing is providing evidence. Therefore, achieving compliance means proving that verification validation was fulfilled. This takes the form of lots of documentation. Our solutions or tools automatically generate documentation, particularly our reporting and analytics web dashboard solution called DTP. Reports can be automatically generated to demonstrate compliance and provide an audit trail. Okay, let's get to the exciting part. I'm going to hand it off to you, Merrick. Over to you.
Thank you, Ricardo. We're going to see how easy it is to create a GitHub workflow with C++ test static analysis, how to access static analysis results in GitHub, and how to download results from GitHub account to VS Code for convenient remediation. For the demonstration, we'll need a GitHub account with a repository for the demo project, Linux workstation with Parasoft C++ test, GNU GCC compiler, and Visual Studio Code, and a GitHub self-hosted runner configured for executing build and test workflow, which we'll set up on the workstation. During the demonstration, we'll go through the following steps. Create a demo repository in GitHub and add an example project to it. Prepare and configure the GitHub local runner. Define the GitHub workflow with the C++ test static analysis. And with all this in place, we'll simulate a simple use case with developer pulling the code, introducing changes using VS Code editor, and pushing the code back to the repository. Push operation will trigger the workflow with static analysis. Static analysis results will be published and available in GitHub for inspection and downloading to the local developer desktop. So let's start with creating a new repository for our demo project. I will switch now to my Linux environment. Let's log in using demo user username and PASS as a password. Now I will open the browser and create a new repository for our demo project. I will call it GHDemo. Now let's add some source code. We'll use popular timer project from C++ test examples. In the home directory, we have C++ test installed. Let me go inside and switch to examples/timer directory, where we have our example source code. This is a simple project we'll be using for our demonstration. Let's add this source code to our fresh repository and commit it. Great! We have some source code in the repository. We are ready to start development. The next thing we want to do is to configure the workflow, which requires configuring GitHub self-hosted runner. We'll use our demo machine as a self-hosted GitHub runner. Let's go to GitHub settings, select Actions, and then add self-hosted runner. GitHub displays a collection of commands for downloading and configuring the self-hosted runner, which we can copy from here and execute in our system. I will open a terminal and create a directory for the runner. Now let's download the runner and unpack it. Great, we are almost there. Now we need to configure the runner. Let's name it Demo Worker and proceed with the default settings. It is now configured and we are ready to run it. Great, our self-hosted runner is up, waiting for GitHub commands. And we're ready to define our workflow. Let's move back to GitHub and set up our workflow with C++ test static analysis. We need to click on Actions and then select Set up a workflow yourself. For our workflow, we'll use a GitHub action for running C++ test that is available in the marketplace. Let's type Parasoft in the marketplace panel, select Run Parasoft C++ test and click here for more details. If we scroll down the action description, we'll find an example of the workflow that is pre-configured for CMake-based projects, which happens to be also used for building our example code. We can copy the entire workflow definition from the actions description and go back to our new workflow and just paste it. Before we commit, let's take a quick look. The workflow is pre-configured to run for main or master branch. We can modify it here to be also applicable for the feature branches. As you can see, workflow is prepared for the self-hosted runners. It uses CMake to build the code. Here we are telling CMake to emit compile-commands.json file, which will be used as an input for the C++ test static analysis. And once the code is built, analysis is executed with the run cpp test action. Action takes the compiled commands JSON file generated by CMake and executes the static analysis. There are a couple of options that can be modified here. You can find more details in the actions description. We'll use the default values for our demonstration, which means that our source code will be scanned with the pre-selected collection of static analysis checkers called recommended rules. Once the code is analyzed, C++ test will generate a SARIF report, which will be uploaded to GitHub and presented as the code scanning alerts. We are ready to commit our workflow now. Let's add a short comment and commit the file. Our commit immediately triggered the workflow. Here, this small dot indicates that GitHub is executing the pipeline. Let's take a closer look. Here we can see steps or actions from our workflow being executed on our self-hosted runner, including, of course, static analysis with C++ test. Once the analysis is done, the started report is uploaded to GitHub and the results are presented in the Security tab's Code Scanning Alerts view. Let's take a quick look at one of reported problems. Here we have a violation of the rule avoid accessing arrays out of bounds. When we click, we are presented with more information. We see the place in the code where problem appears with a comment explaining the violation. If we click Show Paths, GitHub will present step-by-step path with code snippets and additional comments, which is a great help in understanding why and when the problem appears. C++ test integration with GitHub provides a great value here. Ability to review code scanning results directly in GitHub, either in the context of specific check-in or as a part of pull request, streamlines the development workflows and reduces the cost of the compliance process with industry standards. Now let's see C++ test GitHub integration from the developer's activities perspective. For this, I will clone the repository to my local workstation. Let me switch to the terminal. Since this is a fresh workstation, we'll need to perform the initial Git configuration. I'm going to configure now the username and my email. For development, we'll use Visual Studio Code with GitHub and C++ tests extension. Let me open it. As a first step, we need to clone the repository. So let's use clone repository and then clone from GitHub action. I'm already signed into my GitHub account, so I can directly select the repository. When working with a fresh setup, VS Code's GitHub extension will prompt you to sign in. Let's go with GHDemo repository. It will ask about the location. Let's put it in the sandbox folder. We have successfully cloned the repository and we can open this folder in VS Code. The first thing we can do is to download the latest static analysis results generated in the GitHub pipeline. Let's use the C++ test VS Code extensions action to access the results from the latest pipeline. You may be asked to sign in into GitHub, but I'm already authenticated. And as we can see, all the results we could previously see in the GitHub are now downloaded to VS Code. C++ test extension automatically identified the latest results for our current branch. It's a great help and a time saver for developers. They are more productive when reviewing and remediating bigger batches of static analysis violations generated in GitHub pipelines without leaving their preferred IDE. So let's try actually to fix one of the problems. Here we have a violation of do not check for null after the referencing static analysis rule. This is an easy fix. I will modify the code now. Okay. Here we have another violation which we want to accept for now. So I can suppress it. I will enter the reason now. And we are ready to commit the changes and push them to the upstream repository. Naturally, it will trigger the workflow. Initially, we had 5 problems reported. Now we expect 3 problems because we addressed one and one was suppressed. If we go now to GitHub, we can see that the workflow is in progress. Let's give it a second. It finished. We can check the code scanning alerts now. As we expected, there are 3 violations only. Great. This simple use case presents the typical actions performed by developers when working with GitHub. In the real life, development process is likely to be more complex with a large number of feature branches and pull requests. C++ test GitHub integration is proven to support advanced development models. And this concludes my demonstration. Let's quickly recap what we have covered. We have discussed the procedure of adding GitHub workflow with Parasoft C++ test static analysis. We have used the GitHub Marketplace action for C++ test to configure our workflow. We have seen how static analysis results are presented in the GitHub interface. And we have also seen how developers can utilize C++ test VS Code extension and the GitHub integration to streamline their daily activities. Thank you for watching. Ricardo, passing to you for a quick summary.